Okay, so let's go through the maintaining air quality. So let's start on this. Okay, so first thing about maintaining air quality, you first need to know what's the air made up of. Okay, so we're gonna, in this 21.1, we're gonna need to look at what's the percentage composition of air. So all of this over here, okay, nothing really much, but I just want to highlight that this is the key point over here. You need to remember that 78% is nitrogen, 21% is oxygen, 0.04% is carbon dioxide, and 96% is mainly noble gases. Okay, water vapor and other gases as well. So a few things to take note. Take note that when we say 78% is nitrogen, so take it as about 4/5 of air is approximately nitrogen. Okay, and in terms of 21% oxygen, take it as about 1/5 of air is approximately oxygen. Okay, these two percentages you will see it quite a fair bit. So just take note of that. Now, so first thing, composition of air, you realize that it's made up of all these few. So anything that's not nitrogen, oxygen, carbon dioxide, noble gases, and water vapor, generally we most probably will consider them as air pollutants. Okay. So next thing we're gonna look at is, okay, how can we get those air now? Because a huge part of air is nitrogen and oxygen. Actually, if we can extract nitrogen, oxygen from air, we can use it to do other things. So, for example, I need oxygen tank. If I can extract oxygen from the air, I can get tons of oxygen as well. So, scientists actually went on to look at how they can extract oxygen and nitrogen from the air, and how they do so is actually by fractional distillation. Okay. Now, how do they do so? First thing, they take the air and liquefy it. How to liquefy it is actually they cool it down till it becomes liquid. Okay, so how low must it become? Okay, so if you look at all the boiling point here for the nitrogen, argon, oxygen, it's about negative 196. So in this case here, maybe I can cool it down to about negative 210 degrees Celsius. Okay, so as long as it's below the boiling point, then I know that all of them will become liquid. Once they become liquid, I will let them slowly warm up. Okay, they are then allowed to slowly warm up. Okay, and then it will pass through. Sorry, let me erase this. Okay, I'll let them slowly warm up. It's just like heating it up until they start to boil. And when it starts to boil, it becomes a gas, right? We let it go through a fractionating column, and we are able to get the different fractions out. So what's going to happen is the one with the lowest boiling point will come out first, which is nitrogen, followed by argon, and then followed by oxygen. So once at the fractionating column, just think of your regular distillation setup. There will be a condenser, and then it will condense the gas down again. Okay. Now the interesting part is this: it is that when we look at all of these gases here, the condenser doesn't use liquid, doesn't use water to cool it down, because water, the temperature is about 25 degrees Celsius in room temperature. If you were to use water to cool it down, it will not turn back to a gas. It will not turn back to liquid. So I cannot use water. Okay, water at room temperature. I cannot use water at room temperature. Okay, so this one cannot use. Typically, it's a special setup that they will do. Okay, but just take note, the whole process of extracting the different components of air out is by using fractional distillation. Okay. Okay. Next. This question over here. Okay. I just want to highlight. This question is like those kind of typical prelim O-level questions. So they like to test you in terms of how air composition and reactions can come together. So I will just quickly go through this. Let's investigate. So then investigate more oxygen in a sample of clean air. So what they do is they have two syringe, prepare two 200 cm cube syringe. Okay, then they pull syringe A to 100 cm cube mark, filling up with air. Then syringe B is pushed in completely. So if this is full and this is 0, so I know this is 100 cm cube of air. This is 0 cm cube of air. So the total amount of air inside this setup at the start is equals to 100 cm cube of air. Okay. Then what they do is attach the two syringes to a glass tube containing 100 grams of iron. So this one iron over here. They say heat the iron up using a Bunsen burner, push and pull the syringe alternately to pass the air over. So the air will go through it. Then once this one goes out, once the syringe B is filled with air, it will now push through to the other side to go back to syringe A. So they are letting it go back and forth, get back and forth, so that the air continuously pass through the iron powder. Okay, then they say after the whole thing cools down, okay, after the whole thing reacts for a certain amount of time, after 10 minutes, then they allow the setup to cool down, and then they record the final temperature, volume of air in both syringes. So at the end of the day, after all the reaction and everything, they realize I'm left with 79 cm cube. So if I start at 100, and then I end with 79 cm cube of air, you realize that you start 21 cm cube of air. Okay? Now, this 21 cm cube, what component is it? What's the component that's being used up here? So in actual fact, the oxygen, mainly the more reactive part of air, reacts with the iron powder. So this 21 cm cube is actually your oxygen. Okay, so in most reactions involving air, usually it's the oxygen that will be reacting, okay, with the metal itself, okay, or whatever substance it is. So that's why in this observation, it shows that 21 cm cube of oxygen is air. Can? So this is whatever that's mentioned here lah. Okay, next part. So once we are done knowing what is in air, we're going to go on to air pollutants. So anything that's any extra harmful gases apart from the usual composition. Okay, this is considered your air pollutants. So in your syllabus, we actually learned some of the some specific examples. So you need to remember them. So if you look at learning outcome, you need to name and state the sources of common air pollutants, and then you need to describe the problems caused by the pollutants. Okay, and then lastly, you need to explain how they can be controlled. So you also name and state the air pollutants and their sources. You must describe what problem they cause. And lastly, you need to also see how explain how they can be controlled. Okay, so air pollutants are also known as atmospheric pollutants. So look at these two. These two are the same name. Okay, same. They are referring to the same thing. So get used to the terms. Okay, typically they are harmful gases, and they are not found in sample of clean air. Okay, so the rest are stuff. So in terms of the definition, so it's over here. So just take note, it is the introduction of unwanted harmful chemicals into the atmosphere. Okay, that's what the air pollutants are. So in this table 22.2, put a star here. You will definitely need to remember the air pollutants. You also need to remember the sources, and you remember the harmful effect. So let's go through them together. So first air pollutant I need to take note is sulfur dioxide. So sulfur dioxide, where are their sources from? It is combustion of fossil fuels. Take note, it's not just regular combustion of fuels, it's fossil fuels. Okay, so take note of fossil. And next one is volcanic eruption. So there are two sources of sulfur dioxide. Now sulfur dioxide, take note, is a colorless pungent gas. Okay, colorless pungent gas. So actually it's very hard to detect sulfur dioxide just by looking because it's colorless. When you smell it, you can smell it lah. Okay, next one. Nitrogen oxides. Take note, nitrogen oxides refers to this one over here and this one over here. So NO is your nitrogen monoxide. And then NO2 is your nitrogen dioxide. Okay? So NO is a colorless, odorless gas, so very hard to detect. Nitrogen dioxide is a red-brown gas and has a pungent smell, so you can smell it quite easily. Where can you find the gases? So in general, first one, vehicle combustion of engines. The other one will be lightning. Now, what is actually happening here is that nitrogen in the air and oxygen in the air under high temperature. Okay? And then take note, normally with spark. Okay? Or with electricity. That's how these oxides of nitrogen is formed. So actually you got N2 plus O2, you got high temperature, and you need the spark or electricity together. Okay, so that is how the oxides of nitrogen are formed. Now, if you look at the harmful effects, the one I want you to just take note is this. Sulfur dioxide, nitrogen oxides, generally they react with oxygen in the air to form acidic compounds which dissolve in rainwater. This is going to form solution of strong acids, as usually called your acid rain. So sulfur dioxides and oxides of nitrogen, okay, usually will form acid rain. Now, forming acid rain is not the harmful effect. Okay, you must take note, this is not the harmful effect, this is not the harmful effect. Okay, forming of acid rain is just telling you, yes, they will form acid rain. But what is the effect? So the effect is over here. Then I'm going to use this orange to highlight. So they kill plants and aquatic life. That is one of the effect of the acid rain. Second effect is they will corrode buildings and structures made out of limestone, marble, and metals. So in this case here, if I ever want to talk about acid rain killing plants and stuff, you first need to say that the sulfur dioxide and the oxides of nitrogen, they form acid rain, okay, when they dissolve in rainwater. After that, you need to mention that they kill plants, aquatic life, and corrode buildings, marbles, and stuff. So take note of all the points that I highlight. Okay, a lot of people just say form acid rain, full stop. Now, forming acid rain is, once again, it's not a harmful effect. It's about the plants being killed by the acid rain, aquatic life being killed by it, or the corrosion of buildings. Okay? Now, sulfur dioxide has an additional harmful effect. Okay, so let me use a different color. So, sulfur dioxide, they actually cause breathing difficulties in humans and animals. Okay, so they do cause breathing difficulties in humans and animals. So two main harmful effects for sulfur dioxide, one main harmful effect for nitrogen oxides. Okay, next, carbon monoxide. So carbon monoxide over here is a colorless, odorless gas. Take note, it is very toxic. When are they normally formed? What is their sources? So take note, they are formed by incomplete combustion. This is a keyword, incomplete combustion. The word incomplete must be there. Okay, incomplete combustion of what? Fuels. Okay, carbon-based fuels will be the most precise term. Okay, so when you have incomplete combustion of carbon-based fuel, you're going to get carbon monoxide produced. Because why? Complete combustion will actually give carbon dioxide. That's when that's complete. But what happens is that when there's incomplete combustion, that means I got actually not enough oxygen. So each of your carbon is only bonded to one oxygen over here. That's why it's carbon monoxide. Now, what is the harmful effect of this? So carbon monoxide actually binds irreversibly to hemoglobin. Okay, so where exactly hemoglobin is in our red blood cell. So what's this whole idea about hemoglobin or red blood cell? So those who do not take bio, take note, hemoglobin helps us to transport oxygen in the body. So what happens is that when carbon monoxide binds to the hemoglobin, okay, this is where I'm going to use a dark, maybe I use a blue color. Because of this binding to the hemoglobin, it lowers the ability of the hemoglobin to transport oxygen to the rest of our body. Okay, now this is an effect, but how is it harmful? It's really because if you let this happen, this will actually cause us to have not enough oxygen in our body, in our cells. We can either lose consciousness or even death. So this entire phrasing, please take note. Take note of this entire phrasing over here. Okay. Methane. So methane over here. So methane is a colorless, odorless gas that's highly flammable. Now, one of the key things a lot of teachers like say, methane is actually found in fart. Okay, so Fart contains quite a substantial amount of methane as well. Okay, so it's actually a flammable gas. Now, where can I find methane? Where can I find methane? So first thing, if there's anaerobic bacterial decay of organic substance, this will actually form your methane. So the word anaerobic, for those who don't do bio, anaerobic means absence of oxygen. Anaerobic is actually the opposite of aerobic. Okay, so just take note of this. Anaerobic is actually an opposite of aerobic. The other way of forming the methane gas is actually the waste gas from cattle. So when cattle fart or burp, okay, or belch, okay, they actually form this methane as well. So what's the problem with methane? What's the harmful effect? So for methane, do take note, it is a major greenhouse gas and it leads to global warming. Okay? So key idea, what's the harmful effect? Take note, you need to say that it's a major greenhouse gas. Then you can highlight to say its effect, which is it actually causes global warming. Okay, next one, unburned hydrocarbons. Their hydrocarbons are actually, at this current point, you may not have learned hydrocarbons, or maybe you have. So just want to highlight, the hydrocarbons are organic compounds, okay, that contains carbon and hydrogen only. Okay, so as exactly as what the name says lah. Okay, so these are generally colorless gas, naturally odorless. Okay, naturally odorless. So where can you get this? Because they are unburnt, means that actually they are meant to be burned, right? So where are the places where it's meant to be burned but it didn't manage to burn finish? So typically it's in the vehicle combustion engines. So in the engines, all of this fuel are supposed to be burnt, but sometimes due to lack of oxygen or due to the car wear and tear, or the engine wear and tear, okay, some of these hydrocarbons are not burnt. Okay, so take note of this. So once they're unburnt, okay, they get released into the air. So one of the immediate effect, so this is an harmful effect itself already, it can actually cause eye and respiratory tract irritation. So eye and respiratory tract infection, irritation, so you'll get red eye, you'll have breathing, sound like coughing kind of stuff. That's the first harmful effect. Okay. Second one is, it will actually react with oxides of nitrogen, okay, in the presence of sunlight. So not just itself, so unburned hydrocarbon react with oxides of nitrogen oxides in the presence of sunlight. What does it form? It forms this thing called photochemical smoke, which is actually a brown haze. Now, this itself is dangerous to people, okay, so that's why itself is a harmful effect, okay, the brown haze itself. Now, in addition, the formation of the smoke also produces ozone, so it also produces ozone, sulfur dioxide and nitrogen oxides, which are also other pollutants. So realize it's like a chain effect. You got these unburned hydrocarbons, they will react with oxides of nitrogen to form, and sunlight to form photochemical smoke, and then it will in turn produce other things as well. So these unburned hydrocarbons are actually quite unhealthy. Okay, in Singapore, typically they are well managed. Okay, later on we will talk about how we manage these unburned hydrocarbons. Okay, last one, ozone. Ozone we always think is a good thing, but ozone is good when it's in the upper atmosphere, not in the lower atmosphere. So ozone is actually a pale blue gas with a pungent odor. Where can you form? First thing at lightning. Okay, so that's one way. So it's actually where your O2 and another O2 react, okay, and whatsoever, the steps, then you get O3. Next, from reactions between oxygen molecules and sunlight in the upper atmosphere, okay, oxygen and sunlight. Next, reaction between unburned hydrocarbons, nitrogen oxides in the presence of sunlight. So you can see this part here is whatever that we mentioned at the top over here. Okay? So what is the issue? Okay, so these are the sources where you can produce ozone. But what's the issue with unburned hydrocarbons? So once again, they can cause eye and respiratory tract irritation, similar to unburned hydrocarbons. Now take note, there's one additional part. Because of this irritation, sometimes when extreme, it can lead to breathing difficulties. Okay? In addition, they also can cause chest pains and headaches. And the worst thing is, it also affects the plant as well, not just us. okay, actually slows down photosynthesis in plants, which can actually cause damage to the crops. Okay, so these are the air pollutants, their sources and harmful effects. So I want to highlight that, please put another star here. These are important to remember. Okay, important to remember. So how to remember them? Study them first and then do some practice questions, okay, in terms of the sources and harmful effects, and get used to it. Okay, next. Now, acid rain. So we talk about acid rain at the top over here, okay, in terms of sulfur dioxide and nitrogen oxides forming acid rain. So what's the problem with acid rain? We say it kills aquatic life, you know, it can damage plants and stuff. So why is it dangerous? Okay, so first thing, I'll take note, normal rainwater typically pH is between 5 to 5.5. Okay, because naturally occurring oxides dissolve in the raindrops. Okay, dissolves in the raindrops. So this is the usual rain. It's actually slightly acidic already. So rain is usually slightly acidic. Okay, now, but what if there is air pollution? Then in this case here, the rain will combine with the excessive amount of sulfur dioxide and nitrogen dioxide. When it combines, it actually forms a pH of about 40 or 4.0. Now, some of you think between 5 and 4 only drop by pH 1 ma. Now, this 1 pH difference is actually 10 to 30 times more acidic. So pH 4 is actually 10 to 30 times more acidic than pH 5 to 5.5. Okay, so just think, it is not just 1 pH. That 1 pH drop actually is quite substantial. Okay, so what are the issues with acid rain? You can choose to memorize from here. Okay, kill plants and aquatic life, corrode buildings made from limestone, marble, and metals. Okay, this is just a further elaboration of the thing. Okay, now when we look at additional points to take note, so acid rain can also leach essential nutrients from magnesium, such as magnesium and calcium from the soil, which the plants need. So that's why it actually causes issues with the health and the growth of trees. The other one is it lowers the pH of the soil, and some of the plant species cannot live in such low pH, and therefore they will die. Okay, this lowered pH will actually cause them to die. So this is something you need to just take note of lah. Okay, now in addition, aquatic organisms as well, as mentioned at the top. Okay, if the lake water becomes too acidic, okay, when the acidic rainwater go inside the lake or pond, cause the pH to drop out or to fall out of the survivable range, all of these plants and animals will actually die because the pH is too low. Okay, so when there is a lower, when the pH gets too low, when a lot of plants die, okay, this actually causes less biodiversity. Okay, now this biodiversity is a concept that's covered in bio. Those bio would know, but in general, less biodiverse means that there's lesser range of organisms and species lah. Okay. Now, so this part here is an elaboration of acid rain. Okay, because acid rain typically is quite harmful and it affects a huge area. That's why in this textbook here we covered in greater detail. Okay, over here. Now, of course, if there's air pollution, as humans, right, we will typically want to control it. Otherwise, it's going to affect our life. So what do they do to try to mitigate this or to try to control air pollution? So first thing, modern vehicles with internal combustion engines, they actually come with this thing called the catalytic converters. This will actually help us to reduce the pollution they produce. Okay, and in Singapore, generally they undergo regular tests to ensure that the catalytic converters are functioning well and emissions are within an acceptable standard. Next, factories and power plants must obey the legal limits. So they must obey the legal limits of on the emissions. So how do they do so? They will actually install devices and put in place processes. So it's not just devices, they also have processes to manage the pollution. So we're going to cover this catalytic converter, and we're going to cover the processes that's involved in factories as well. So catalytic converter in the internal combustion engine, then we're going to cover the processes in factories and power plants. So first thing, catalytic converter. So where is the catalytic converters? They are actually located midway in the exhaust system of the vehicle. Okay, it's typically between the engine and the muffler. Okay, so should be this one over here. Now, in addition, okay, what exactly is in this catalytic converter? So this is actually how it looks in real life. This is how it looks in real life. So key idea here is that in this device, there's a coating of catalysts. What are the catalysts involved here? There's platinum, palladium, and rhodium. What do these catalysts do? They actually speed up the conversion of harmful substances in vehicle exhaust to less harmful substance. So the key idea here is there's this conversion that they help out with, and they speed up this conversion. Okay? And do take note, it is arranged in a honeycomb structure. What is the special thing about this honeycomb structure is that they actually maximize the surface area for gases to interact with. The more surface area we have for interaction, the reaction will actually be better or faster. Okay? So this is two things here. So I put catalyst. Sorry, I realized. I put the catalyst inside. Next thing, I design it to have honeycomb. Okay, honeycomb structure. Okay, so I can maximize the surface area for the interaction. So usually for engines, right, before catalytic converter, it contains these 8 gases here. Now, which are air pollutants? Carbon monoxide is, nitrogen dioxide is, nitrogen monoxide is, unburned hydrocarbons. So there's these 4 air pollutants. If I don't do anything about it, it will be released in the air after the car moves, and this will actually cause quite a bit of air pollution. So what they're gonna do is they are gonna do reactions at the catalytic converter. Okay, so 4 main reactions. 1, 2, 3, 4. So first one, the carbon monoxide and the nitrogen monoxide, they'll actually react to give you carbon dioxide and nitrogen. And we know that these 2 are good. They are not your air pollutants. So all is good. So this is the first reaction that can happen. So why is this able to take place? Because I got a catalyst over here. Okay, so the catalyst actually helps to make the carbon monoxide and the nitrogen monoxide react to form my carbon dioxide and nitrogen. Next, another reaction to help remove carbon monoxide is that the carbon monoxide can react with oxygen further. Okay, so because there's incomplete combustion due to lack of oxygen, right? So at the catalytic converter, I introduce more oxygen in. I put a catalyst in between, so there's a presence of a catalyst. It will actually help to let these 2 bind better, and I'll get my carbon dioxide. So this is another process that helps to remove carbon monoxide. So first process actually removes CO plus NO. Second process here actually removes CO. Third process, I got nitrogen dioxide. So what the catalyst over here does is it splits it up into nitrogen and oxygen. So this one here removes NO2 by splitting it up into N2 and O2. So once again, because of the catalyst over here, okay, there's a catalyst in the reaction that allows for nitrogen dioxide to break down. Last one, okay, I got unburned hydrocarbons. I let it undergo combustion. So actually this is a combustion reaction, and this actually helps to remove unburned hydrocarbons. So key idea here is that because you got unburned hydrocarbons, you want to make sure they burn finish. So then you let it in the presence of catalyst, let it undergo some reaction, okay, for it to disappear. Okay, and then I get carbon dioxide and water vapor. So realize all the end products, all the products are actually safe. Okay, all the reactants, okay, the reactants here, they're actually the unsafe thing that you want to remove. Now, I just want to highlight this point that is being made by the book. So even though catalytic converter increases the amount of carbon dioxide, so you realize a lot of the reaction, right, involves an increase in the amount of carbon dioxide. But this is still a preferred air pollution control. I'd rather have more carbon dioxide than to have carbon monoxide, nitrogen dioxide and stuff, because all those are the real air pollutants. Your air already contains carbon dioxide. Okay? So therefore, by increasing carbon dioxide and reducing the other air pollutants, this is still a better choice. Okay, this is still a better choice. Okay, so just take note of this. And I will just want to highlight this point here. Catalytic converter reduces pollution but does not eliminate it. Okay, so there are definitely other ways we can do to try to reduce air pollution even more. Elimination is definitely not possible in our current world, so it's always about reducing it as much as we can. Okay, next one. This is about power plants now. Okay, about the processes in power plants. So they have this thing called the flue gas desulfurization. Flue gas desulfurization. So what exactly is this? So let's go to the basic concept first. So fossil fuels in general, they always have sulfur content inside. So fossil fuels tend to contain sulfur. Okay, fossil fuels tend to contain sulfur. Because biological molecules actually would generally contain your sulfur lah. Okay, so that's the key idea. Now, because power plants, they actually burn fuel such as coal and fuel oil. Okay, they actually produce high amount of sulfur dioxide. Okay, because all of these fuels, like the coal and the fuel oil, contains sulfur. Okay, now the carbon dioxide gas that's produced in the exhaust is known as flue gas. Okay, the exhaust which is like the gas that's produced from the waste incinerator, they are known as the flue gas. Okay, so instead of letting this air get released, then there's tons of sulfur dioxide, which can actually cause acid rain. So they actually undergo this process called, so this is the process I need to take note, it's called the flue gas desulfurization. So what exactly does it do? Okay, it will actually remove a significant proportion of the sulfur dioxide from the flue gas, okay, before it's released in the atmosphere. So in the process here, before the waste gas is released into the air, they will let it undergo this flue gas desulfurization to remove the sulfur dioxide. Okay, remove the sulfur dioxide. So the most wide used method for flue gas desulfurization, which we're going to cover here, is actually what we call wet scrubbing. Okay, wet scrubbing. So how does this wet scrubbing work? Is that they have this, they actually use this thing called the calcium carbonate slurry. So what is this calcium carbonate slurry? Slurry is like a mixture of solid, okay, and liquid. Okay, mixture of solid and liquid. So this solid here is undissolved, or I should say, mostly undissolved lah. So the slurry is formed when calcium carbonate in the form of limestone is mixed with water. So this is the solid, this is the liquid. Okay, so this solid, which is quite fine in that sense, grinded, mixed with water, so you get like this slush, okay, this slush type of material. So when the flue gas, that's containing sulfur dioxide is produced, they'll purposely let it pass through this chamber, okay, this container lah. So as it goes through this purification chamber, they will actually let the slurry, okay, get pumped. They will actually spray the slurry onto the flue gas, and this will actually cause a reaction that will form calcium sulfide. So calcium sulfide is actually a product from it. Then what happens is that all the gas that comes out here will have a lot lesser SO2. Or you should say, in this process, we try to eliminate lah. But in general, normally, you won't eliminate all one. There may be still some traces of it left, but it will be like super a lot lesser. So typically, because it's so much lesser, we take it as IR. Okay lah, clean gas. Okay, mainly carbon dioxide and air, and there's no more sulfur dioxide present. Okay, so this reaction here, you can see here, what it's trying to do is that because SO2, okay, is actually if you all remember in your acid bases and oxides, this is actually an acidic oxide. Okay, acidic oxide. So if it is reacting with calcium carbonate, you realize it is actually the case of mentioned here. So it's actually an acid carbonate reaction. Okay, because sulfur dioxide is an acidic oxide. So what happens is that it's like macam acid plus carbonate. So I'm going to get carbon dioxide gas produced. Okay, so calcium sulfide is like the salt, and then carbon dioxide gas is produced. Why is there no water is because in this case, this reaction here, normally it's acid plus carbonate, then you get the water. So the acid usually is in the aqueous state, right? So that's why aqueous tells you that it contains water. So the water is actually present there. But in this case, because it's a gas reacting with this carbonate here, that's why there's no water produced in this case. Now, calcium sulfide is not that useful. So you look at this formula here, CaSO3, not SO4. That's why it's FITE. So take note, calcium sulfide is formed, not calcium sulfate. Sulfide is actually SO3 2 minus. Okay, this is not your usual sulfate, this is sulfide. So sulfide is not, calcium sulfide is not so useful. So what they typically do is they let the calcium sulfide undergo further oxidation. This will in the end form calcium sulfate. Okay, and how do they let it undergo oxidation? Is by letting oxygen in the air react with the calcium sulfide. So what you're going to see here, calcium sulfide plus oxygen give you your calcium sulfate. So this calcium sulfate is actually generally quite useful. Okay, why? Because they can be hydrated. So you add water to it to form hydrated calcium sulfate, to form this thing called a gypsum. Okay, so this is the reaction over here. This gypsum is produced, can be used to make drywalls, fertilizers, plaster for sculptures, casts, okay, for fractured bones. Okay, and this is also an essential ingredient of making tofu. Now, after saying all this, then most of you will ask, do I need to remember all of the steps here? Okay, so flue gas desulfurization, do I remember? Catalytic converter, do I need to remember? Yes. Okay, so I want to put a star at flue gas desulfurization. I want to put a star here at the catalytic converter. So knowing what is happening for the catalytic converter and the flue gas desulfurization, these two you need to remember. Okay? Remember all the equations as well. Okay, so just take note of these reactions. Okay, now so all this here is just a further explanation for it. So I will just tell you this one, you just read up lah. There's not much like special detail to really take note of it. Okay, this one really just going to read up because it's about whether we why is it that it's not done every single place lah. Okay, so yeah, maybe this one here just tells you why flue gas desulfurization is not set up every single place. This one here actually tells you how they control soil acidity. Okay, for forests and water bodies lah. Okay, so liming. Now go and read through this one yourself. I won't go through this one. Okay, next, ozone layer. Okay, so ozone layer. We're going to now focus on the ozone part. So we're going to discuss the importance of ozone and how chlorine-containing compounds such as CFCs can deplete the ozone layer. So what is the purpose of ozone? So the ozones actually block out UV radiation. Okay, that's the purpose of ozone. Ozone actually helps to block out this UV radiation. So although ozone is a pollutant found at the ground level, so although ozone is considered a pollutant when found at the ground level, actually the presence in the upper atmosphere, to be more precise, upper atmosphere, is actually beneficial. They absorb ultraviolet radiation and reduce the amount of UV radiation that reaches Earth's surface, and hence we don't get too much exposure. Okay? So the ozone can be found in the stratosphere, which is the upper atmosphere. Okay, now, when is ozone molecules formed? So ozone molecules form when the oxygen molecules interact with the UV radiation from the sun. So ozone has a formula O3. Please remember, it is an allotrope. So allotrope is actually same element but with a different structure / arrangement. Okay, so you can see here O2 is oxygen, O3 ozone. So they are the same element, but the arrangement itself is different. One got 2 oxygen atoms on it, the other one has 3. Okay, so as mentioned previously, ozone pale blue color, pungent smell. Okay, you can actually find them in electronics. So typically when burning electronics, or like when doing soldering, or like filing your electronics, all of this typically they are quite toxic lah. So they will tend to have exhaust gas to suck. They'll be tend to something to suck the gas away. Okay, whenever they are doing it with electronics. Now, as much as ozone is formed by oxygen molecules, the ozone molecules also break up to form oxygen as well when they absorb UV. So that's why it's a reversible reaction. So take note, remember in your Haber process, you learn this arrow, it tells you that it's a reversible reaction. Okay, reversible reaction. Now, so we talk about how ozone is formed and then how ozone reacts. Next, we're going to talk about how ozone is being depleted. So you know ozone is good in the upper atmosphere, but you know that we got this thing called the ozone hole, right, in the upper atmosphere. So how is this ozone layer depleted until it got hole? So key idea here is last time, in many of the substances that we use, they actually contain this thing called the chlorofluorocarbons. So they're actually carbon compounds that contains both your chlorine and fluorine. Okay, so typically refrigerators use them last time, aerosol propellants, okay, and certain plastics also contain them. So when they go up into the air, they can actually interact with the UV radiation to produce chlorine atoms to react with the ozone, and then it actually destroys this / breakdown. Actually the word breakdown ozone, and hence there's lesser ozone. Okay, so how exactly does this work? So see this, first thing, UV radiation. So this is the whole diagram, we can use this to explain. So UV radiation from the sun breaks up the CFC molecules in the stratosphere into chlorine atoms. So first thing is this step here is the formation of chlorine atom. Okay, so you can see chlorine atoms over here. Now, second step, these chlorine atoms will actually react with ozone to form oxygen and chlorine oxide. So this is your first step. Let's say reaction A. So you can see here my ozone is depleted already. Okay, my ozone is depleted, lesser ozone. Now, this chlorine oxide, let me use a different color here. Okay, this chlorine oxide actually continues to break up another ozone molecules, which then produces a chlorine atom. So this part here is the reaction B. The chlorine oxide reacts with another ozone to give you back your chlorine atom, and then formation of oxygen. Now someone says, sure, oxygen good what? Not good meh? But the key idea here is if your ozone keeps getting depleted, there's lesser and lesser ozone to shield us from the UV radiation from the sun. Okay? Now I want to highlight this. Do you realize that this reaction, right, with a chlorine atom at the start, after reaction A and B, I get back a chlorine atom. So you realize this is like a chain reaction. Okay? The Cl does not get depleted. It can just go on and on and on. The more chlorine, the faster the reaction will go. And the chlorine doesn't get depleted because the chlorine will get regenerated. So for every 2 ozone that's depleted, the chlorine comes back alive again. Okay? So this is a very scary reaction because it can just goes on and on and on with just one chlorine being present lah. Okay, and because of that, holes in the ozone layer will start to form, and then harmful UV radiation will reach the Earth's surface lah. So it's not just about oxygen being formed, yay, good but really, having the holes in the ozone layer actually will cause us to actually die because all the UV ray will come down, and then people get skin cancer and stuff Okay. So all of this here, just take note, they are just sharing, how actually if we do something about pollution and environmental sustainability, we can reverse the harmful effect. So there's always hope. Okay, there's always hope. Okay, next one, carbon cycle. So we mentioned about ozone layer itself and then how to protect it because of UV light. So why is it that part there? Why is the ozone mentioned here? It's because ozone is a pollutant at the lower atmosphere, but not a bad thing at the upper atmosphere. Okay, so we're looking at how the air quality is key here, right? Next one here is carbon dioxide. Why the carbon cycle here? Because carbon cycle looks at how carbon dioxide is managed. Okay, how carbon dioxide is managed. So carbon monoxide, though, is in our general composition of air, but I need to take note, carbon dioxide is a greenhouse gas. So if it's a greenhouse gas, it actually contributes to global warming and climate change. So global warming is the first thing. By having global warming, it actually contributes to climate change. So please don't just straight everything climate change, climate change, climate change. The correct way to write the whole thing is, typically for carbon dioxide, we know it's a greenhouse gas. This will contribute to global warming, and then because of global warming, it will lead to climate change. This is the sequence of steps. A lot of people like to just write climate change. Pollution caused climate change. Please, it's not like that. You must know how the effects are led up to lead to that climate change itself. Okay, so what is this? Why must we talk about this carbon cycle, right? Because we want to manage carbon dioxide. So how is it being done? So we know that burning fossil fuels actually causes carbon dioxide emission. So we can actually plant more trees to reduce, the carbon dioxide emission. So how does all these things work? That's where we talk about the carbon cycle. Okay, carbon cycle. So now, key idea, why is it called a carbon cycle? Actually, anything that contains carbon is included. Generally, we are looking at the flow of carbon dioxide in this case here. Okay, so it's not just carbon, the element itself, but carbon in the form of carbon dioxide and other things. So element carbon is essential for all life, yes. All organic compounds, take note, all organic compounds are made of carbon. They have carbon skeleton. Okay, and that originates from carbon dioxide and water during photosynthesis. Most organic carbon on Earth is contained in the cells of living things, as fossil fuels and plastics that we make from them. Okay, and as fossil fuels and plastics. So cells in living things, fossil fuels and plastics all contains carbon. So it's about how to manage all of this carbon over here. Okay, so think of the carbon cycle in terms of the process. Okay, carbon cycle is actually the set of processes that regulates the amount of carbon dioxide in the atmosphere. Okay, so I need to regulate the amount of carbon dioxide in the atmosphere. So think of this as atmosphere. Okay, so I'm thinking of what contributes CO2 to the atmosphere, what takes away CO2 from the atmosphere. Okay, so go to this diagram over here. Now, so what takes in carbon dioxide? So what reduces the amount of carbon dioxide in the atmosphere, which is a good thing, is actually photosynthesis. So the more trees I have, so when I got more trees or more plants, okay, this will actually allow more carbon dioxide to be taken in with water, okay, in the process of photosynthesis to make glucose and oxygen. So photosynthesis helps to remove CO2 from the atmosphere, right? From in the general air. Next thing, ocean uptake. So oceans and other large body of water actually they absorb carbon dioxide. So this one once again also remove CO2, okay, from the atmosphere. And then the marine plants actually use this dissolved gas to photosynthesize as well. Okay, now when the water absorb, so what happens is that we know that the ocean absorb, right? So when they absorb this carbon dioxide, they are actually also converted to carbonic acid and calcium carbonate that makes up the shell of marine organisms. Okay, so they don't just exist as dissolved carbon dioxide, they actually form your carbonic acid, they'll form your calcium carbonate in the shells of marine organisms. Okay, so these two processes help to remove CO2 from the atmosphere. But what releases CO2 to the atmosphere, so this one add CO2 to atmosphere, is your respiration. Okay, so living organisms gain the energy of life processes by breaking down glucose back into carbon dioxide and water. So this carbon dioxide is then released in the atmosphere. Okay, so you can see the cycle here. So this two removes, this one add. So it's sort of like a process that helps to control the gases going in. Sorry, let me go back to the correct page. Okay, so this is the general cycle if we look at the living things and stuff. So with human activity, so in the normal natural processes, these are the few things to take note. But once human activity comes in, okay, there are other things that add to the carbon dioxide in the air. First thing, because we burn a lot of, we want to produce energy, right? So we burn fossil fuels. So combustion actually adds CO2 to the atmosphere. Okay, adds CO2 to the atmosphere. Okay, so they burn in the presence of oxygen, and then carbon dioxide is actually a product, so it adds to the air. Next thing, if a lot of decomposers die, they actually also are broken down. Decomposition also adds CO2 to atmosphere. Okay, so decomposition breaks down. Okay, they release CO2 with this aerobic. Okay, then the other one is anaerobic decomposition, also traps carbon deep in the Earth's surface as well. So when you look at decomposition, there's both aerobic and anaerobic. So take note of these two differences. One actually will, in the presence of oxygen, they release CO2 in the atmosphere. The other one is in the absence of oxygen, then they actually trap carbon. Okay, they trap carbon deep in the surface. Now, 22.5, we look at global warming and climate change. So these are last few parts already. Okay, so we need to state that carbon dioxide and methane are greenhouse gases. They contribute to global warming. And then next one, we look at how global warming can lead to effects like climate change and melting polar ice cap. Okay, so this part here, a bit of common sense, so I can go a bit faster now. Okay, really lesser chemistry lah. Okay, so we're going to look at how global warming occurs and how it causes climate change. So first thing, what exactly is global warming? Global warming itself it's not climate change. Global warming is just the increase in average temperature of the Earth's surface due to increasing amount of greenhouse gases. Okay, so the two greenhouse gases that I talked about was CO2 and CH4, methane. Now, greenhouse effect. Okay, so if our greenhouse gas, it actually causes greenhouse effect, and this actually causes global warming. So how exactly is this greenhouse effect over here? So we can see it in the diagram. So when the Earth's solar radiation reaches Earth, some of it is reflected into space. So this is the reflected into space. Reflected into space. Let me use a different color blue. Okay, reflected into space. Okay, then some of it passes through the atmosphere to become heat. So this is the become heat. So if I look at it as reflected into space as A, passes through the atmosphere as B, so this is A, this is B. Now, as the Earth's surface is warmed, some of the heat rises and escapes into space. So this is the part here. So when Earth is warmed, the heat escapes into space. Now, so what happens is that as in space, the remaining heat that's trapped by the greenhouse gases further warm the planet. So this part here where the greenhouse gas is, okay, they will actually cause the heat to be reflected back, and then causes the Earth to be warmer. So the more greenhouse gases I have, the warmer it will become. Okay, so These are the major sources. I will not go through them. Okay, you already know already. So just take note of methane and carbon dioxide as two main sources of greenhouse gases. Now, so global warming, just need to know this diagram over here, okay, and see how it works, and then know that the two major sources are your carbon dioxide and methane gas. All these are just additional info for you to read and get a sense of the severity of it. Now, then, what exactly is climate change? So take note, climate refers to weather conditions over a period of time. Okay, so it can cause by a few things. First is ocean temperature, wind speed, direction, and humidity. And since temperature across the world is increasing, temperature across the world, this one talks about global warming. Okay, this means that this will lead to climate change. So what are some of the effects of climate change? Changes in rainfall patterns. Okay, you can just read this, but know the header. Header is the most important one. So climate change, one of it is changes in rainfall patterns. Second one, there's heat waves. Okay, you can read this on your own. Normally they will just ask you what does climate change causes. So heat waves. They will cause tropical storms. Next, they will cause ocean warming and acidification. So a lot of the plants, the reefs will actually die. Then we also have the glacier retreat and the melting of polar ice caps. This is also another factor. Okay, so you can see here the climate change phenomenon and then what's their effect. So this table is the one that I'll tell you, please go and memorize it. Okay, this one is key here. Anytime when they ask you what's the climate change phenomenon and what's the effect. So these two, please make sure you link them up. Okay, so lack of fertile land, so lesser food produced, lack of food produced, more heat wave, so high temperature lethal, especially for elderly and the frail. If I got more extreme weather such as typhoon and tornadoes, especially there's increase in strength as well. Property destroyed, lives lost. Okay, it will actually cause decrease in fertility of farmland as well. If there's ocean warming and acidification, coral reefs are bleached, marine habitats are lost. Okay, commercially important fish population will also be gone because aquatic life will die. And also the shell of crustaceans, that means, example, your lobsters and crabs, will actually be softer. Okay, and hence they're actually less protected, they'll die even easier. And last one is the melting of polar ice cap and glacial retreat. This will cause the river levels to change, actually to be increased, to be more precise. So sea level will rise and cause coastal area to be flooded. Okay, so yep, that's the end of this whole climate change here. So you realize that there's a lot of info. So all this info, you need to just take note to memorize them. Okay, if you don't want to memorize them, very simple, you just practice enough so that it becomes a part of your regular knowledge. Okay, so key here is practice until you don't need to memorize them per se lah. Yep, so that's all from me.